here. Don't go there. All right. Technician A says the engine coolant temperature and intake air temperature sensors can be tested visually as well as by using a digital multimeter or a scan tool. Technician B says the engine coolant temperature sensor is a high authority sensor at engine startup and is used for open loop control as well as idle speed.
I know you can't look at it and tell the temperature.
B's.
By looking at it.
I think B's.
Yeah, I think B's right.
Well, this is just a really crazy question. They can be tested visually as well as by using a digital meter or scan tool. Okay, let me ask you this. How would I use a digital meter to check an engine coolant temperature sensor?
You can open the zero. So the voltage you want into the thing?
I would actually do that. Just what Tyler said. What I would do is I would take that sensor and I would use like a little T-pin or something, you know, that's a little shiny little T-pin. You know what T-pins are. It's like a little straight pin that's got a little T at the top. You ease that thing in there, go in there and back probe the connector very gently. And when you go in there, you touch your meter to ground and to that T-pin where you've gone into the wire. There's two wires going to it, and they're what? What are those two wires? One of them is signal return. It's a ground going back to the computer, right? Everybody remember that. The other one is the signal. If you disconnect the sensor and measure that voltage, what are you going to see?
Zero.
Volts.
4.6. Usually about 4.6, because there's another resistor inside the computer on the 2-wire sensors. On the 3-wire sensors, you got a straight 5 volts coming out, and then you got one that changes with the position or pressure or whatever that sensor is measuring, and then you got one that's a ground. So if you go all the way as far as it will read on a 3-wire sensor, you're going to read about 4.6. If you disconnect an engine coolant temperature sensor, you're going to have 4.6. Right. So I would measure it if I was going to do that, and that's what I did before we had serial data. In other words, we didn't have a scan tool that would tell us anything except pull codes until about 1989 or 90 at Ford. And I actually started going and measuring the voltage on all of the sensors and getting used to what they were supposed to be. And I fixed all kinds of cars without ever cracking the book.
What you remember?
Because I remembered what the voltage was supposed to be. I'd go in there and I'd say, okay, we got something that sounds to me like it's related to engine coolant or intake air temperature because this one's running a little rich or it's not, you know. And I'd check, whoop, look at that engine coolant temperature. It's supposed to be reading what? When it's cold, it's going to be reading what? If it's negative temperature coefficient, that means the hotter that sensor gets, the lower resistance goes. The lower the resistance goes, the lower the voltage goes because it's shortening away, right? Got it? Okay, so if I go out there to a really cold car, give me a ballpark, JT. I go out there to a really cold car and I back probe the engine coolant temperature sensor. I ought to read about what? Just shoot in the dark, huh?
About 3.
Roughly 2 to 3, somewhere in that ballpark. When I crank it up, whenever it warms up, it gets down to where a thermostat opens. It ought to be just below 0.6 of a volt. That's 0.6. And if I see that happening, I kind of know it's okay. On a Ford Taurus, like a little 92 model that Gene had in earlier this morning, when the engine coolant temperature sensor gets to 0.45, the coolant fan comes on.
Okay.
And so if I take a potentiometer that I bought from Radio Shack for not much money, that's got the right amount of ohmage, which is like 30,000 ohms or something like that. Usually I think 50,000 is fairly common. Hook that thing up so that I can dial that coolant temperature voltage down. I can make that fan, fool that computer into making the fans, make the fans time to come on. Boom, fan comes on, run it back up, it waits a little bit and turns it back off. I've already checked it without even getting the motor hot. And you can check it just like that. All right. One of the reasons I'm doing this thing right here, lecture, to start with, I'm helping you guys get tests done. Secondly, I'm telling you stuff I'll forget to tell you if I don't do this. And this is the stuff I'm telling you, stuff you will not read in the book. Now, the book is good stuff. I ain't said don't read the book, but I am saying you're going to hear stuff from me that you're not going to hear in the book because I did this for years and years and years and years. And I don't know everything, but I learned a heck of a lot while I was out there. That's the point. All right. Now, this is a story here. I mean, the answer key on this one here, I'm going to tell you the answer key says that A is the only one that's right.
On number 1?
Mm-hmm. I don't know why that is, but that's what the answer key says. Yeah. Greg, what did you find on that one when you looked it up? Because you did.
I found both of them.
That's what I thought. I'm like you. I'm thinking both those guys are right, and I'm thinking the answer key needs to be corrected. What do you think about that?
Email.
What do you think about that, Babel? That's it. It's time for an email. All right, I'm gonna go in here and I'm gonna do a
Why are you doing that?
two.
What are you gonna do?
Are you sleeping?
Huh?
Yep.
You wake up.
Is he sleeping or freaking?
He's sleeping.
No, he's getting a cup of coffee. Okay, so I'm gonna say both those guys are right.
Both
Yeah.
A and B.
Both A and B.
A and B.
Both A and B ought to be right. That's what I'm gonna say. That is my thought about that. Both A and B. That one there should be a C, which would be a both A and B. Right?
So you want us to put A answer key or?
No, just put C because you're going. Whenever y'all get through with that, you're gonna. All right. So on the next question. Oh, I'm gonna tell you something else too, and I may have said this before, but I want you to pay attention to it. Let's say, listen. Maybe some of y'all will remember this, but I try to throw the mud on the wall till it all sticks. You go out there and you plug your scan tool in, and you're looking at all your sensor readings. And I want to know if the thing's been sitting there for 4 or 5 hours, right? Let's say somebody parked it way a while ago, and it's been sitting there for 4 or 5 hours, and I'm wanting to know if I can trust all the temperature sensors. So I've got a transmission oil temperature sensor that's in the transmission. I got an engine coolant temperature sensor that's in the engine coolant, and I got an intake air temperature sensor. It's either in the breather, or it's built into the mass airflow, or it's in the intake manifold. All right, I'm going to pull all those up on my scan tool, and if it's been sitting there for 4 or 5 hours and it hadn't been moved and nobody's been running the engine, all of those ought to be really close together because of the second law of thermodynamics. All the heat, everything's going to be the same temperature when it's been sitting there for a while, right? All right, what if I go in there and I see engine coolant temperature, and like it's a cold day outside, chilly day, engine coolant temperature 46 degrees, transmission oil temperature 45 degrees, intake air temperature 101.
No, such as bad.
And then I'm in my enhanced side of my scan tool. I back out of the enhanced side of my scan tool and I go into the OBD2 side, which is a different room. You got a choice between going into the enhanced or going into your OBD2 generic. I go into OBD2 generic and I look at intake air temperature, and it's the same thing. Engine coolant 46, transmission oil 45, IAT minus 40. Why don't the OBD2 and the enhanced agree?
So those sensors bad.
Because that software in that PCM, if it knows the sensor is not reliable, it substitutes a value that it believes will work. It's kind of in the middle. You see what I'm saying? All right. So
OBD2 side, right?
as the OBD, no, that's the enhanced side is going to give you that 101 degree number or whatever, whatever it decides to substitute that it believes will work. It's like, I know that 40 below zero is hogwash because it's just not that cold here, and it's never that cold hardly anywhere unless you're in Siberia or North Dakota or somewhere. And so, yeah, it can get that cold up there. But anyway, the point is, it says I'm going to drop a number in here. Well, the problem with that is, if you've got engine coolant temperature sensor that's 46 degrees, and you got intake air temperature sensor that it has substituted 101 degrees, what is it going to do with the gas when you're starting the darn thing up? It's going to flush so much gas in there, it's going to flood the dadgum thing. Now, this is what happens at a body shop calls me over there when I used to go sometimes on Fridays to work at the Ford dealership in Dothan, just help them with problem vehicles. And I went over there to the body shop, says, we got a Dodge truck that came in here, and I talked about this one time in here before, a Dodge truck that won't start, and it was running just fine when it came in here, check engine lights on, but it was running just fine. And so we finished all of the work we were doing on it, and when we got through all the work we were doing on it, we tried to start it up. And when we got it, tried to start it, you spin it over, and it won't start, and you smell gas. And we're trying to figure out what's wrong with it. Well, that's what I found exactly what I'm telling you guys. I figured out several things on that one truck. First thing I did was I checked it. When I pulled the spark plugs out, they were wet with gasoline. And so I just threw a set of spark plugs in it right to start with because, you're used to trying to clean them spark plugs. Let's just throw some in it, And but I found out as I was perusing my scan tool that it's just like I said, the intake air temperature says reading 101 on the enhanced side, on the OBD2 side is reading 40 below. So I measure the voltage there, and even though it's plugged in, I get 4.6 volts, which is the real high voltage. All right, so I said, well, that ain't worth a toot. I'd already tried to start it, and it wouldn't start. Just like I said, I unplugged the intake air temperature sensor. I got a potentiometer that I just had, borrowed from Donnie because he had one in his box, and I got a couple of wires And let me show you how I did this, because y'all already need to know this. Pay attention to this, because it's important. All right, I got a little potentiometer, which is a potentiometer like I'm talking about, y'all. Looks like this. You see that? You can buy those little potentiometers at Radio Shack. They don't cost hardly anything, but you need one that reads about 50,000 ohms. Got that? It's a 50,000 ohms. And it's got a resistor in there that goes all the way around and hooks up, each end of the resistor hooks up to these outside ones. And typically that middle one's the one that changes readings when you turn the knob. All right, so I got a potentiometer, and you got 3 little legs on it right here like this. This is down in dirty stuff. You can make you a tool like this. It's cool as all get out. Get you a project box for a couple of bucks. One of these, get you some little connectors that you can plug, test leads in. All right. Now, unplug my engine coolant temperature sensor wire from the sensor. Sensor's here in the block and all that. All right. I got 2 of these legs, and I hooked 2 of them legs up to my wires. Right. I got one of the end legs and the middle leg. Usually if you hook it up to both sides, it's not going to change anything when you turn the knob. You're not going to burn anything up this way. You're just going to have fun, right? Looking at your scan tool, I hooked up 2 of the legs on this end, and I could turn my knob. And my scan tool, I would see the temperature reading start to change with the key on. Looking at the scan tool, I saw it start to change, and I dialed the temperature down so that the intake air temperature is reading the same as engine coolant. I dialed it down to where I was giving it a truthful number about this 46-degree air that we had outside. And when I did that, I hit the key, boom, fired right up. Well, see, you're actually telling it the truth instead of the sensor lying to it. Well, the funny thing about that was it had a brand spanking new sensor in it. And this is how this thing played out. The guy's got this Dodge truck. Check engine light pops on, but it's warm weather. See, as long as it's warm weather and engine coolant is fairly close to 100 degrees, it's going to start just fine. Well, one day you wake up with a cold snap, and now the darn truck won't start. Well, but what he first did when his check engine light came on, for whatever reason, he goes to AutoZone or somewhere. They plug in their little scan tool. They pull the code. They find a code for an intake air temperature sensor. They go get one off the shelf that's made in China or something. It ain't worth a darn, only they don't know it. They screw it in there. They plug it back in. They're still getting the same code. They say, well, you got some kind of a wiring problem or something. We don't know what's wrong with this. He says, well, it's still starting okay. I can live with that light. And then all of a sudden the cold snap comes, and he's sitting over there at the house, late for work. And he's smelling gas, wet his plug. And all. See how this stuff works? If you understand how this thing thinks, you can fix the fuel injection stuff real easy if you understand how it thinks. Now, occasionally there's going to be tough problems, but that wasn't all that hard, but it was fun, you see. Because I was able to trick that thing out. You can use that to trick out the thing and make the fans kick on and all kinds of stuff. And I got one of those I put in a box in there made for this purpose. Next one. Technician A says all temperature sensors decrease in resistance as the temperature increases. Technician A says all temperature sensors decrease in resistance as the temperature increases. This is called positive temperature coefficient. Really? Is that right?
No.
What's wrong with what he just said?
When the temperature increases, the resistance gets higher.
Yeah, whenever the sensor gets hotter, the resistance goes down, and that's called negative temperature coefficient.
Okay.
So they just screwed that all up. I'm going to tell you something else too that I don't like in any kind of a question or any kind of, I'm really skeptical about a lot of these. Any kind of question that says always, never, all. I'm bothered by that. Okay, the next one, let's look at it. Technician B says some vehicle manufacturers use a stepped engine coolant temperature sensor circuit inside the PCM to broaden the accuracy of the sensor.
That's right.
That is correct. Now, what does it mean to have a stepped sensor?
Step sensor?
Yeah. The Oldsmobile has one. You can plug that thing in, hook your scan tool up. You're watching your engine coolant temperature sensor voltage. If you drew it on a graph, and I could actually put it on the screen out there, on the scope screen, the voltage is going to start out up here, and as the engine warms up, that thing's going down, going down, going down, going down. And it's going to come to a certain temperature, and it's going to shift gears. And when it shifts gears, it's going to go up, and it's going to go down again like that. And that will confuse the tar out of you if you don't know what's going on. But it happens on some of the Chryslers. It happens on some of your GM products. So it's actually going to shift gears in midstream. It's going to get down to where this voltage is about to go off the chart. Well, when it gets down this low, it can't be all that accurate because of the the voltage band available gets narrower. So they want to broaden the voltage band and make it accurate all the way up. So they shift gears with it. Now, not every engine coolant temperature sensor does that. But if you see that happening, don't think that they're because that circuitry is built in. So that one, next one is a B. Number 2 is a B. Technician A says, other temperature sensors that operate like the ECT sensor include transmission fluid temperature or transmission oil fluid temperature and engine oil temperature. Engine oil temperature. Where would we see something like that? Johnny's probably around those every day and might not even. Huh? Engine oil temperature sensor on what vehicle? Huh? You ever seen one of those? On a Power Stroke, it's got engine oil temperature. A 7.3 Power Stroke, the old 7.3 Power Stroke diesel engine with electronic diesel, it couldn't care less about the doggone engine, about the engine coolant temperature. Hello? Hey. All right. I don't even have an account with them or know anything about them. I don't even know who they are.
Johnny, where did you go yesterday?
Yeah, I could probably get set up to, but I don't have an account with them. I'd have to go, set all that stuff up.
I'll just tell me where I was going.
That's what I'm told.
Well,
I don't care. Get it for me. All right.
I just went.
All right. All right, so it's Technician A, right? Other temperature sensors that operate like the ECT sensor include transmission fluid and engine oil, right?
Yeah.
Technician B says all temperature sensors increase in resistance as the temperature decreases.
Yeah. Both right.
Is that, does all of them do that? Did your book say all of them did? Are you sure? I'm just playing the, asking questions here. Yeah. Now all right, everybody listening to me? Listen. Where's all these private conversations coming from? Okay. Do all temperature sensors operate like negative temperature coefficient?
No.
What did I just say a few minutes ago? If it says always or all or never, I'm a little skeptical of that.
No. Here
Well, if you look far enough, you'd find one that didn't. The correct answer to number 3 is A. If you've had to change your answer, you will get that one wrong. All right. If I can tell that you've erased the answer, that one gets marked out. Okay. All right then. All right. I said that because I saw Greg changing his answer over there. Oh, of course, it ought to be worth something. It has to stand here and listen to me talk for an hour, hasn't it? You know what I'm saying? You ought to try this. You know how much it takes out of you to stand up here and talk for a solid hour and make sense? You know what I mean?
Yeah.
Think about it.
I'm a dummy.
All right, now then, a stepped engine coolant temperature circuit is being described. Technician A says the sensor used for a stepped circuit is different than the one used for a non-stepped circuit. Technician B says a stepped ECT circuit uses different internal resistance inside the PCM. And who is right?
Both are right.
The only person is B. B is the only person that's right. We're getting this from people that have never cracked their advanced engine performance book. They're just trying to sail through on the lecture. You know what I'm saying? You better be reading that book, guys. All right. Because we're not going to go through the final exam like this. You understand what I'm saying? You're going to look all that stuff up. It's better if you've already seen it once. When testing the engine coolant temperature sensor with a connector disconnected, the technician should select what position on the digital multimeter?
Volts. AC volts.
Now, wait a minute. Listen to what it says, Greg. When you're testing the engine coolant temperature sensor with the connector disconnected, what are you going to be reading if you touch both of the pins on that engine coolant temperature sensor connector?
5 volts.
Ohms.
There you go.
Connector?
Give that man a cigar. You're disconnecting it, and you're testing the sensor.
Oh, I thought you just said.
We're reading the question, and you should be listening. If I didn't know better, I think you were texting with your phone or something. Now listen to what I'm telling you when I read this. When testing the engine coolant temperature sensor with the connector disconnected, the technician should select what position on the digital multimeter. All right. I feel a lot better now that we're all on the same sheet of music. When checking the engine coolant temperature sensor with a scan tool on generic OBD2 mode, about what temperature should be displayed if the connector is removed from the sensor with the engine off. I just talked about that about 5 minutes ago.
You said -40.
-40. Bingo.
I ain't gonna leave.
And look at this, guys. Sometimes I hit people with this for a trivia question. What is the equivalent of 40 below 0 Fahrenheit in Celsius?
0.
-40.
Oh, Fahrenheit and Celsius, it's gonna be
40 and 40.
Same thing.
yeah, same thing.
That's where they cross. And look at your paper. It's got it in parentheses, -40 Fahrenheit equals -40 Celsius. That dumb cowboy. Love you saying that. All right. Now, two technicians are describing the intake air temperature sensor. Technician A says the intake air temperature sensor is more important to the operation of the engine than the ECT sensor. Is that correct? So you got to break these Technician A and Technician B questions down and make it like you're answering two different questions. That's how you work with that. Technician A says the intake air temperature sensor is more important to the operation of the engine, which would be higher authority, than the ECT sensor. Technician B says the PCM will add, wow, that's interesting. They foul that question up. Technician B says the PCM will increase the fuel injector pulse. They put add increase, which is totally dumb, but it was a typo. I've done those before. Occasionally I make a typo, but not very often. Okay. Well, increase the fuel injector pulse width to the base calculated pulse if the IAT indicates the incoming air temperature is cold. Okay, think about this. Where does the pulse, where does the PCM get the idea how many times it needs to pulse the injector and how often it needs to click it?
How much air is coming in?
No, well, listen up. I'm not talking about how long to hold it open when it clicks it. How does it get an idea of how often to click it? Or, what frequency to click it?
Engine RPM?
Yeah, I get it from the crank sensor.
Yes.
Reference signal from the crank.
Yeah, it's stored, right?
It's going click, 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 and it's going to sound, yes, they're going to be clicking like that. Okay, so each time that injector clicks, it can have different authority. In other words, different amount of pulse, excuse me. And the sensors, the main authority on how much fuel it's going to put in there, it depends on the type of fuel injection system it is. You have speed density systems, which is what?
Speed density?
Yeah, and then you got density speed systems, and you got mass airflow systems.
Map sensor?
Yeah. The map sensor is actually going to tell it the density of the air in the intake. So if I've got low vacuum, what does it tell me about my load?
Low vacuum?
Okay, you race car
Load's
bus.
higher.
Huh? You load higher load is lower vacuum, right? If you got a vacuum gauge on your car, you put it in drive, hold your foot on the gas, your needle's going up. I'm talking about it's going to go closer to zero. It's going to go close to atmospheric pressure. When you let off and it's idling, throttle plate's closed, engine's sucking on that throttle plate, you're going to have higher vacuum. Well, it just so happens that your fuel injector can, your engine controller can say, I can take manifold absolute pressure and I can determine how much fuel we need. We call it map sensor, but actually if you take barometric pressure, it's 30 psi, which is equal to 14.5 pounds per square inch. And you pull, it'd be like 30 inches, So what you got is each pound per square inch equals 2 inches of vacuum pretty much. So about 14.5 is equal to 30 inches of vacuum. So you're going to, if you're looking at inches of vacuum, you're looking at, 2 inches of vacuum per pound per psi. That's in a metric. How do they measure that in a metric system, by the way? Pressure, any kind of pressure, huh?
Bar.
Bar. What is a bar? That's a good answer, but what's a bar?
Barometric pressure?
And how would you what's one bar?
1 bar is 1 psi. Is
That's 3
1 bar is
3 psi.
No.
14.17.
14. Yeah. Well, no. You're thinking about stoichiometry.
Anyway,
14.5 pounds per square inch at sea level, pushing on all sides is your air. It's like an airplane fly.
14.5 psi is 1 bar.
Yeah. It's pushing equally in every direction at sea level. We got 14.5, and that's 1 bar. That's 1 atmosphere. In the medical field, they call that atmospheres. You know what I'm saying? If you're going up 2 bar, you're going up 2 atmospheres. which an atmosphere is like at sea level. Okay, so you got 14.5 is 1 bar, you know, and twice that is 2 bar. And you'll see gauges. They'll say 1 bar, 2 bar. Well, that's pretty coarse. You know what I'm saying? We like pound. I mean, we like inches of vacuum or pounds per
There's
square.
a house that goes up to 22 psi,
Mhm.
and it goes when it gets to about 14, in between 14 and 15 psi. It's a bar right there. One
Yeah,
bar.
there you go.
And then it gets a
Yeah, you
line.
were close. That's why you knew that. You were putting that together. That's pretty smart. All right, so anyway, that's 1 bar, 2 bar. All right, I was trying to make sure you understood all that. So your injector, PCM calculates injector pulse based on manifold vacuum. Right? You got that? Remember, what did I tell you the other day that the PCM did when you let off the
It's off your injectors.
injector gets shut down? Why do they need to be on anyway? You're not pulling anything, you know, just remember what I said the formula read? The way the formula reads is if you got a calculated pulse width less than 1.2 milliseconds and engine speed over 1200 RPM, the injectors are shut off. Close the throttle, coasting down, shuts off the injectors. Meanwhile, while all that's going on, your PCM is looking at the crank signal and it's getting its profile correction, or what Chrysler calls adaptive numerator. It wants to know what's normal for the crank whenever there's no misfires. And that's the stuff it has to learn. Okay, so here's what we're doing. We've got a situation here where we were trying to answer this question. 2 technicians are describing an intake air temperature sensor, and technician A says IAT is more important to the operation of the engine than the ECT. Is it or is it not? If I disconnect my intake air temperature sensor, is there going to be a problem?
Yeah.
I mean, how much of a problem is it going to be? Is it more of a problem to disconnect the engine coolant temperature or the intake air temperature?
Yeah.
You know, the engine coolant temperature sensor is going to be more of a problem than the other. Well, why is that?
Because it won't tell the fan to kick on.
The engine coolant temperature is going to be fan issues. There's going to be idle issues. There's going to be fuel, pulse issues and all that. If I've got an engine coolant temperature sensor that's failing in range, and what does that mean?
Then
That means it's reading between the range the PCM expects, but it's not telling the truth. If it's off one side or off the other, that's an out of range failure. Okay, got that? So, all right, number 7. We got to figure out what number 7 is. We got to be able to look at these questions and answer them. Everybody in here should be able to pass the ASE test when we're through with all this, right?
yeah, when can we take the ASE test?
Anytime you want to, when you want to apply for it.
Right.
Jesse James Duke paid $242, took all 8 of them, passed them all.
Wouldn't WIA pay for them?
No, they're not going to pay for the ASE
Pay
test.
for ASE test out of pocket?
Yeah, you do. That's a good thing though, because whenever you get your certification, then you're a hoss. That means you go over there and they say, you say, I'm ASE certified in engine performance, transmission, engine repair, and brakes. And they say, God, this guy's already got some certification. We need to put him to work.
What's
That's
Jesse
the way they're
James
working.
doing now?
Huh?
What's Jesse James doing now?
He's working at a shop over in Level Plains. Found a shop he likes to work at, and that's where he's working. Anyway, technician B says powertrain control module will increase the injector pulse if the IAT indicates the incoming air is cold. Well, that is true, right? So that's B. According to the answer key. So see, IAT is not more important. I got to get this stuff burned in. If I just go through here and just give you guys the answers without giving you any kind of background information, you're going to leave out here dumb as a brick, and you're not going to know anything more than you did when you came in here. So burn this stuff in. That's why I'm videoing it, so you can watch it again if you need to. Amanda brings me a jump drive and has me put my lectures on her jump drive so she can watch them later. And I did a 1-hour lecture on emission controls one time way back about 5 or 6 years ago, and I figured nobody's going to watch this nonsense. And I put it on a computer, and those students watched that over and over. I couldn't believe it because it was boring to me. You know what I'm saying? I mean, I enjoyed giving it, but I couldn't imagine students watching it over and over. And it was an hour long. All right, if the transmission fluid temperature sensor was to fail electrically open, infinity resistance, like somebody had cut the wire, how would the PCM change the up and down shifts? That is a good question, isn't it? They would disable torque converter clutch normal shift points. They would have normal shifts and normal operation of the torque converter clutch. They would have normal shift, but overdrive would be disabled. They would have delayed shift points in torque converter clutch disabled.
Yeah.
It seemed like it would be delayed. Delayed shift points and torque converter.
Let me ask you this. What is the torque converter clutch? Somebody tell me what it does. What's the point in the torque converter clutch? Why do we even need one? We don't need that silly thing. What do we do with it? What's it helping us with?
Overdrive?
Nope. Ain't wrong.
I almost came up with something then.
Yeah. Think about that.
It builds up like RPMs, don't it, or something? I mean, not RPMs.
Oh, I know what it does.
What?
In between
It's
shifts, it keeps the motor okay instead of dropping RPMs and having to go whoa and shift real hard.
Ain't wrong.
Oh, it's close.
All right. What the torque converter clutch does is it provides a direct coupling between the engine and the transmission.
Okay.
It comes in typically in third gear, your direct gear, and it stays in all the way through overdrive. But you can disable your torque converter clutch and still have your third gear and your overdrive. But there's going to be some slippage between the engine and the transmission, right? Okay, when your torque converter clutch is engaged, what is not happening? The torque converter is not making heat. Because when that torque converter is shearing that fluid, it's just all the heat from the transmission just about is coming from the torque converter. That's why it leaves the torque converter, the fluid does, and goes to the radiator goes to the transmission cooler, and then comes back and dumps in the pan. All right, now, hear this. Whenever your torque converter clutch, whenever your engine is cold, the torque converter clutch will not lock. It will not lock a torque converter clutch when it's cold. Got it? You understand that? Torque converter clutch usually comes in roughly about 45 miles an hour, depending on the
Is that
vehicle.
when they say your converter's locked in? Mm-hmm. Like you gotta go. Let's say I go out and I got an automatic transmission and I buy a not a converter but a stall converter, and the clutch don't lock in to a certain RPM. Like that stall makes it so you can press the brake and get up on it. Make RPMs go higher. And then when you let off, it'll jump RPMs and lock in.
I don't know if they make one of them high stall speed converters that has a torque converter clutch in it. They might.
I don't know.
I don't think they do. I think they probably leave that out of there because you don't give a rip. What is it good for? Besides the fact that it keeps the transmission from overheating. Because the torque converter clutch will lock in if the transmission starts to overheat, so that it can help cool it down. On a motorhome, it actually locks in at 22 miles an hour. Because of the tremendous amount of energy that's being expended. Anyway, I kind of got off on a rabbit trail there. Normal shift, but overdrive will be disabled. That's what the right answer is. But my torque converter clutch is going to be disabled too. Overdrive is what? What's overdrive?
Direct link transmission rear end. Direct link transmission.
No, that's third. That's before overdrive. Overdrive is whenever the drive shaft's turning faster than the engine.
Is it always third? Because most of that 5-speed is fourth gear.
Well, it moves around a little bit, but there's a direct range, and overdrive is above that direct range. The gear ratio for overdrive is like 0.76 to 1, so the engine is turning slower than the drive shaft in overdrive. And that's why you don't really want that when you're pulling a dadgum heavy trailer. So you hit your tow haul button if it's a Chevrolet or your OD button if it's a Ford, and it kicks it out of overdrive. You still got torque converter clutch, you see, but you got no overdrive. But anyway, incidentally, the way this thing is written, you're going to drop your overdrive if your transmission oil temperature sensor is not working.
What makes a transmission fail in overdrive if you try to pull something like Greg's transmission in his truck? Is Dodge transmissions are real bad about if you try to tow something with your OD on. Even if it's
overloaded. It's like being in too high of a gear.
Yeah, it's like,
Yeah. Huh? What? No, the answer on that one's C.
So, Mr. Richard, mine had an 84 Cutlass, and I was driving it, and I wanted to burn the tires on it. And I ain't no better then, so I was putting it in neutral and gassing it and dropping it in drive to make it get a wheel. And I did that a couple of times, and then the transmission wouldn't go. It was in drive, it wouldn't go anywhere. And my uncle came over there, and I was scared because I knew I was going to get in trouble. And my uncle came over there and told me to put it in drive 1, and I drove it home. Yeah. But I don't understand what was going on.
Now, did you have it? Did it work after that in the other gears?
No, I didn't. Yeah.
Well, what happened? What you actually did when you were doing that was there's a bunch of little teeth in there, and whenever you do that, you strip those off of there. You know what I'm saying? 'Cause it's not really made to do that.
Flywheel or what?
No, inside the transmission, there's some little little clutch. You had to just wipe those out.
Oh, that's what I did.
Yeah, you sheared those little things off. Yeah, and that's you see them do that on movies, but they they got infinite transmission money on movies. All right. So. Diagnostic. What I was saying earlier, I don't want to confuse you about that, but your torque converter though is not going to lock in, and it basically is not looking at transmission oil temperature; it's looking at engine coolant temperature on that one. So because they're trying to warm everything up quicker, so that's going to disable the torque converter. But overdrive is the one that will be disabled if the transmission oil temperature sensor is bad. is open. Diagnostic trouble code P0118 is being described. Technician A says the ECT, engine coolant temperature sensor, could be open internally. Technician B says the signal wire could be open. Who's right about that? Both of them. If it's open, if you got a cut wire, it's open internally. Now then, you all know whenever if you cut the signal return wire, which is your ground wire going back to the computer, let's say you're reading your TP sensor voltage right here with your voltmeter, and it's like 0.8 of a volt, and as you go up with the TP, with your throttle, it's going up to 4.6, and you go back, it goes back to about 0.8. What's going to happen if I've got my voltmeter plugged into that engine coolant temperature sensor signal wire, and I cut the wire that's the signal return, that's the ground going back to the computer? What's the voltage going to do at that sensor? No. I cut the ground.
Oh, so it's
going to go to 5 volts.
Yeah.
And so if you've got a signal return wire that's been snipped, see, if I wanted to be a jerk and I wanted to throw y'all a really hard job, something to fix, I'd go find the signal return wire right there at the computer, go clip. And every dadgum sensor on the thing's reading wide open then. And the smartest thing you can do is see if you got a good strong ground, going back to the computer on signal return. Wow, we got a signal return open here. And I've actually seen people accidentally somehow hook 12-volt power to the signal return wire, and inside the computer, and then all of a sudden we got a no start, we got all kind of issues. If it does start, it runs poopy. You know, it's just awful. All right. All right. Now then, let's go down here. So, wait a minute, 9 is what?
9 is C.
9 is C. Diagnostic trouble code P0113 is being described. Technician A says. Now, you know that PO is the generic code. If it was a P1 something, it'd be the manufacturer specific code, right? Mm-hmm. Well, what if it was a P07 something? What would that be talking about?
Drivetrain?
Transmission.
I was close.
Close. How about that? So, there's a reason, around the reason of the codes. You got to understand that. Okay, P0113. Technician A says IAT sensor is internally or electrically shorted. Technician B says the PCM could be defective. And who's right about that?
B.
It's not going to be a B as a boy, right?
Man, your wife is smart, Greg.
Okay, so what did your book say about that, Greg? What did it say about a PO113? What does that mean?
I was going to back up.
Yeah. I mean, what was the answer you came up with?
B.
A B? You came up with the same one I came up with, huh? All right, then. Be thinking about that.
It's in the book.
Yep. Number 11. Number 11. Got it? Diagnostic trouble code P0117. DTC is being described. Technician A says the engine coolant temperature sensor internally shorted to ground. Technician B says signal wire could be open. Who's right about that?
B.
That's going to be an A. That's going to be an A. I tell you something else too. Well, some of on your Fords, if you're doing key on engine off or key on engine running test, if you put it into test before the engine warms up, it'll throw you coolant sensor codes because it ain't warm, and it may throw you oxygen sensor voltage codes too because it didn't warm it up. So, in the what?
My truck, right? I can't start with the key. The key won't start on. The button does. Kick the key on like you're starting it, and it'll kick the good on, hit the button, and cranks up. What happens when I'm driving on the road and I'm starting with the key?
What's that now?
The key in my truck.
Yeah, you say it won't start it. Is everything still hooked up?
Everything works except for it don't go to the ignition wire. It don't hook to the starter. It don't kick start on it. Now, turn the key over, just kick it, let it go. Just all the lights show up and the fuel pump kicks on. Start with the button. That's the way it kicks the starter on. What happens if I'm driving down the road and I want the key, like I'm starting it?
Well, it depends on where the problem is on the truck. I mean, it depends on what part of that circuit is.
Oh, the only thing that's wrong with the circuit is the little thing. You turn the key over, and you turn it over, it pushes that little rod down there and hits the little thing. That's the only thing. It needs to be adjusted.
So what happens when you turn it over? You ought to be able to answer that better than I
You go
can.
to start, go into start mode.
Yeah.
And kick all the injectors on. Or excuse me.
No, it's not. Well, just try it sometime. See what happens.
I did. I can't tell the difference.
No, you probably won't. If it won't start the truck, then it's not knowing you took.
I got my car like that too. Hot wire.
Yeah.
No, whatever. Right.
I bet they want you to.
Hot wire. You got
All
to
right.
turn the key and push the button.
In the below illustration, what type of circuit is being depicted, William?
Catch up.
An oxygen sensor, a negative temperature coefficient thermistor, a step-up transformer, or positive temperature coefficient thermistor? Now look at the words.
I'll go C or D.
Well, we got a PCM, we got 5 volts coming through a resistor and then headed out to a sensor. We got a return coming back through a ground, and we've also got, just past the resistor internal to the PCM, we've got a signal being measured. So you got higher voltage when the sensor is cold, lower voltage when the sensor is hot. I'd say that's a plain old negative temperature coefficient thermistor.
No, it's close enough.
Not that complicated, is it? Is that right?
No.
Okay, Ben, that next question is for you. The intake air temperature is being tested. After the vehicle has been allowed to cool for several hours, we use a scan tool to observe the intake air temperature, and we compare it to the engine coolant temperature. The two temperatures should be within how many degrees of each other? That is number 13. I kind of gave you all the answer to that earlier when I was talking. What was it?
25.
25 degrees.
10.
So you're telling me it's okay if my engine coolant temperature sensor is reading 50 and my intake air temperature is 75? And it's been sitting for several hours?
Did you say within 5?
It's going to be the smallest number there in a situation like that.
Oops.
Ben, I'm very disappointed. Actually, I'm just giving you a hard time.
Yeah, no.
You did okay. You're just sort of sailing through here anyway.
I should have.
The next group of questions is from Chapter 12. So turn your books to Chapter 12. And the people that didn't bring their books says, yeah, right. Okay? All right. Technician A says the 3 wires on the TP sensor include a 5-volt reference voltage from the PCM. And Technician B says a TP sensor is a 3-wire variable resistor called a rheostat. Who is right?
No, it is. It's Lawrence, man.
Sure, thank you.
Dang.
What phone was it?
In the bathroom?
That's one of those high school
Hey
students.
man, don't be touching my screen now.
Yeah.
Oh, it's a high school student's phone? Is yours?
Is that yours?
Yeah, that's mine. You
I'm
know,
sorry.
I'm the one that got a phone like that. Everybody got to look at it like, look at this old phone.
See all them girls have been calling. All right. All right, yeah, thank you, ma'am. Yeah, it wouldn't hurt. It wouldn't be a bad idea for you to do that.
You get chips out there?
AFC
They got
12.
good, man.
Let's see. 3881. Okay, that one, you know where that one goes. You know where all these go. So. We'll sign that one. Sign that one. We have to sign our requisitions because it keeps us out of trouble. Now this one here goes to Miss Meredith. Here you go.
I've been here.
I don't tell you that yours. Know that.
Sorry. My brother recommended
Thank you very
the car on Saturday night. I had to
All right.
go down there on Friday.
Ma'am?
And then
The
yesterday.
one that's not a car.
Monday,
You know, the one that's
Friday.
got nothing. If it doesn't have the little red number for a car, it's going to go to her.
I thought you were going to the car Friday.
I was.
Okay.
I saw that morning. I was going to go with my mom.
Okay, is Technician A right? Technician A says the 3 wires on the TP sensor include a 5-volt reference voltage from the PCM. And Technician B says a TP sensor is a 3-wire variable resistor called a rheostat. Is it called a rheostat or something? It ain't called a rheostat. What's it called?
You said it yesterday.
Oh, it's not thermistor, but
This thing I was holding in my hand a while ago.
It's
Can't come up with the name of it.
Starts with a P. No.
Starts with a P. That's right.
potentiometer.
What?
Yes, potentiometer. He got it right. I can name that tune in one note. That's cool. He would have won the game show there. Okay.
Game show stuff right there.
Yeah. Technician A says the 3 wires on the throttle position sensor include a 5-volt reference voltage from PCM, plus the signal wire to the PCM, and a ground. Is that right?
That's right.
Technician B says the TP sensor is used by the PCM for torque converter engagement and transmission shift points. He's right about that.
I don't know about transmission.
Both of those guys are right.
Oh, yeah?
He sure is.
You skipped it too.
I tell you, one of the cool things about the some of the cars that Chrysler had that were they cross-engineered there with Mitsubishi back, was how many of you guys have driven your car with cruise control on and you're thinking, okay, I'm gonna try to save some gas here, and then you start up a kind of a hill and the stupid cruise control kicks it into passing gear, and you didn't want it to do that. You know what I mean? Well, all those Mitsubishi cars that Chrysler was, it was like some of the cars Chrysler had that we were working on, that they had something called fuzzy logic. And what it meant was the PCM knew the cruise control was engaged, and instead of shifting it into the lower gear when it ordinarily would, it would say, well, this guy's got cruise control on, and we know that he really doesn't want it to shift into the lower gear, so let's just not make that shift this time. And it was a different driving experience for somebody with cruise. If they had the cruise engaged, it wouldn't do that.
You know what's even better for mine? Yeah, stick shift. I put it one gear on. Cruise control. This is what I tell you.
I don't like that cruise control. I feel like somebody else driving the car or something.
Yeah. That's not so bad. It'd be a Terminator car.
Oh.
Anyway, this guy, Mark Shipes, was driving his Jeep, just like a silver one out there. And you know that Jeep, if you're driving them Jeeps, you got Jeeps, don't you? You're a Jeep person. And if he's like, he can tell you that if you got that Jeep in its power curve, you ain't got the brakes to stop it. I mean, because of the torque that it's got. I mean, those things are really strong. And as a matter of fact, whenever that gray Jeep came out, it would spank anything in its class for torque. You know, I mean, it was just really. So,
of course it does.
yeah. Anyway, it was here's Mark Shipes driving this thing. And they said sometimes the cruise control won't disengage, and so he tapped the brake and it would disengage. He tapped the brake and it disengaged. He tapped the brake and it disengaged. And he just called, fat, dumb, and happy. Oh, this is just a fun test drive. I can't get this thing to do anything. He's coming up to a traffic signal down there on the traffic circle. I mean, all that. He hits the brake. It wouldn't disengage. He hits the brake a little harder. It says, we're slowing down. We need more throttle. Whoa, like that. Next thing you know, he's got his old big muscled up leg standing on the brake as hard as he can. The Jeep's doing a burnout. He goes, he can't think fast enough to scared of, and it wouldn't do it every time. But, because if you know it's going to do it, that's one thing. And he was just sort of, laid back because he didn't figure, but it was actually boiling the tires. And he was trying to come to a light down there. Oh, scared the stew out of him. He was goosey anyway. All right, so watch that. Watch the cruise control. Okay. All right, now then. Skip number 15. I'm sorry. All of these are functions of a TP sensor except what? All of these are functions of a TP sensor except what?
Air conditioning compressor clutch operation?
No. It actually, if you got wide open throttle, it's going to drop the compressor out. If you do things with the torque converter, like if you go all the way to the floor, it's going to drop the torque converter too. Clear flood mode is what?
That's the...
Clear flood mode is I can go out here on one of these cars that's got fuel injection, and if it doesn't have gas puddled in the manifold from a previous operation, I can pop that pedal all the way to the floor and hold it there, and that thing will not start.
Yeah, I remember you said that.
Like that. As I told John, my nephew, and then we go out there with your girlfriend and all that. John don't know about a car. He plays the violin. He's smart, but he, got his Corvette started whenever I talked to him on the phone about it. But the morning, I said, you take your girlfriend out there to the burger barn or something. You're sitting there and to get ready to start, and of course, if it starts up, you got to let off the gas real quick. But I said, hold the gas pedal all the way to the floor. And she's going, oh no, we got car trouble. And, well, listen, I think I can take care of this. So he pops the hood and he piddles around. He don't even know what he's doing up there. Gets back in there. Yeah, I got to take care of him. Oh man, she thinks he's the man.
Yeah.
When they see you fix the car, they think you are the living in.
Or they think that he's a piece of crap car. I'm not dating him again.
Well, so this thing's just temperamental. I think I can take care of the problem here, So anyway, you can fool somebody. Well, I used to do that on the engine coolant temperature. On the SPDS machine. When I'd put it in self-test, I had 7 seconds before it would go in self-test. If it's an engine running self-test, first thing it does, it advances the engine and the ignition timing, and it kicks the IEC open to the maximum speed. And I would say, I'd punch that button, and I'd have like 7 seconds, and the customer would be standing there, and I'd say, I wonder if this thing will just respond to voice commands. And I'd say, can you speed up a little bit for me? And it would go, the customer. Well, I knew it was going to do it, but it hoodooed them, And I was like, that other guy, that salesman, was walking by one day when it was getting ready to do that, and he just kind of caught my eye when he was walking by, and I went, just pulled my hand out like I was doing some force thing, or something. He's looking at me like, and trying to figure it out. All right, why is hoodoo to me? All right. Let's see. Technician. A typical TP throttle position sensor registered about how many volts in idle.
Once again, you deny.
Hey, you gotta give us an answer for 15.
You don't know? I went through all the rest of them except the one that was the answer.
Flood mode.
It's actually determining rich and lean air fuel mixtures. It doesn't do that. What determines rich and lean air fuel mixtures? Oxygen sensor, right?
Oh yeah.
Yeah, it's a feedback, right? Typical TP sensor registered about how many volts at idle? You can tell this guy that loves GM, because usually they're about half a volt. A Ford's about 1 volt.
B.
But half a volt's the only answer that works for that. Half a volt. B, half a volt, half a volt. A throttle position sensor is which of these sensor types? A piezoelectric, a potentiometer, a rheostat, or voltage generating?
C.
See,
Okay, what's a piezoelectric?
A.
Knock sensor. That engine knock hits 5,555 hertz. You get a signal from your knock sensor, retards the timing a little bit and make it go away because it thinks it's a spark valve. Right? All right, what I got here, a rheostat's what you got. Well, you got a rheostat on your car somewhere usually, on a lot of cars, but the thing that you dial your dash lights up and down with, that's a rheostat.
oh, okay.
Yeah.
You know that.
And
Broken
then
into-
you got voltage. What? All right, hold on. Voltage generating. Got a couple of kinds of sensors that do that. One of them is generates voltage, makes its own current. Ain't getting nothing from nobody, just makes it.
A piece of quartz.
Oxygen sensor.
Oh yeah, because it gets so hot that it makes current.
600 degrees. It's got an electrolyte, that's ceramic zirconia, up and down. All right, what's another one that generates voltage? What about a crank sensor?
Yeah, the
Kind of
magnetic.
voltage is sent to it. You know, whenever that thing goes whirling past, you know, it shifts the field back and forth, generates AC current, or AC voltage too. Okay, a typical throttle position. Wait a minute. Yeah, I'm sorry. A typical throttle position sensor registers how many volts at wide open throttle?
4.5.
About 4.5. Yeah, where are you going to get on that? And if you're checking your throttle position sensor with your meter, if you and this is a little blurb. This is something I'm giving you for free. So be watching this. You plug your throttle position sensor. You know, you ground your meter. You go to your signal wire on a TP. You're seeing about 1 volt on a Ford or about a half a volt on a Chevy or something in between those. And you go up really slow and you watch your meter really careful. If you got a minimum current maximum, that's good too. And if that ever drops out while you're going up, then you got a bad sensor. You know what I'm saying? If it climbs real pretty and goes up to the 4.5 volts and then comes back down, it's okay. But if you're going up with it and all of a sudden let's say it goes 1.5, 2, and then all of a sudden 1, and then 2.5, 3. Then you got that's a bad sensor. Trash that one.
It's got a bad tooth on the sensor.
I need to try it.
Throttle position.
It's not a tooth. It's actually a place where it has rubbed the little. This is the TP sensor. Inside there, it's got this little resistive paint, and over time it wears out. This is where the throttle hooks to it right here.
Because on that Cobra I was telling you about,
Yeah.
it's got a bad tooth on the little thing that goes tick in there. Because you can turn it and
Yeah,
clicking.
yeah.
It's got a bad tooth on it.
Now
It's got
that
a
one
bad
is
spot.
probably one that's wire wound.
Yeah, it is.
Yeah, so that would be a different one. Most of them have got resistive paint on real cars.
We were doing a burnout in Panama City because everybody's like, do a burnout, And anyway, whoa, lit the tires up and it started stepping out and sliding a little bit. So he kind of corrected the wheel and it hit that dead spot. Boom! They just cut it off and the wheel locked and we're like, oh! And we started rolling.
All right. We were possum hunting one time with 4 guys in the front of the truck, and the guy got his knee against the steering wheel. The guy that was driving had never felt that before, and he thought the steering locked up. Hold on, boy, she's locked up. We're going in. You ever been driving with too many people in the cab? Somebody gets their knee against the wheel, all of a sudden you can't turn it. Okay, country boys all done that. All right, so we got right here fuel-injected engine has a higher than specified idle speed with the engine at normal operating temperature. Technician A says the throttle position sensor signal voltage may be higher than specified. Technician B says the engine may have an intake manifold vacuum leak. Who is right about that? That's actually a technician B, but I don't agree with this knothead's question. I'm going to tell you why. I talked before the other day about this Ranger that would run away. Not say run away. You come to a stop. You're used to seeing your engine speed go down to the normal place like 700 RPM or something, and you go and you stop. You go and you stop, and it comes down, and then all of a sudden you stop, and it stays up to like 1200, and then you slap your throttle, and then it may come down, may not. Well, if you ever took your scan tool and plugged in there, when you crack off of idle, when you crank the car up, whatever voltage it sees at that throttle position sensor, it's what it pegs at idle, as idle. It says, okay, that's what I'm going to use for my idle voltage. That's why it's so important, if possible, to keep your foot off the dadgum accelerator when you're starting it, because it needs to see what that base voltage is whenever you crank it up. Okay, so if for some reason you got problems with your wire or your crimps in your connectors or something, so that, what did I tell you was going to happen if you cut your signal return wire?
Higher.
Voltage goes to 5 volts. If you have resistance in that crimp joint on your signal return wire, that voltage is going to drift up. If it drifts up and it says, I don't see part throttle yet, I'm going to leave my idle speed control on dash pot mode, because I want to idle it down. When we come back to idle, I want it to idle down slow. I don't want it to slap down idle fast, because it'll stall the engine, and customers don't typically like that very much, okay? So what happens is I haven't seen base, idle speed, and so I'm going to hold my idle air control open, and the customer's sitting there going, why is this thing running fast? And then you jack around with the wires a little bit at the TP sensor, and it goes, because you've disturbed those little things. That's why you take these little wires out, unplug them from the connector, make sure you remember what order they came out, stand them up, solder the crimp joints, put them back in, usually fix them suckers every time.
I've seen where that car, like you go to stop at a red light or something, it's a stick shift or something. You go stop there.
Okay, did everybody learn something here today? We've been in here for 56 minutes and some change.
Wait, 56 minutes is some change. Still not quite $1 yet.
I got some change.
I got some change too.
Yeah, baby, that's what I'm talking about.
Thanks
All
for
right.
me.
Give me some change, man.
Who said we got enough to go around?
Well, these are thanks to Bill for that. You guys have some.
Let me borrow $100 and I'll pay you $5.